All right, we're like super live now, like really, really live. Great. Yeah, we have a couple more minutes. We'll get everybody in, get everybody to their seats. I have it open so people can just come on in. We'll do some introductions, get everybody going. See some familiar faces out there in the crowd today, Andrew.
Awesome. Thanks everybody for joining. Appreciate it.
Yeah. Put some we have to put some security on the door for your celebrityism. So I had some bouncers, I paid some bouncers at the door just to make sure you're good to go.
Thank God.
Yeah. Everybody in.
Why is it I can't share my screen?
Oh, uno momento, por favor. Oh, you should be able to. You're
I'm trying.
Yeah.
Can you see it?
No.
This is
Oh. Was there an update? Is there new settings?
this, yeah, it's the new version of Mac OS.
Yeah.
Great. How do I do this now?
If you can send it to me, I can pop it up for you. All right, we'll get people start coming in. We did have a reminder that went out this morning to let everybody know, remind them about the webinar today. So yep, I can pop it up for you if you need to. I don't know, did the doors get locked on the way in? All right, people are coming in. Here we go. All right, so good morning, everyone. It's right at 11 o'clock, so we're going to get started because we do have a lot of content to get through today with Design Point and also with a couple of things at Mass MEP we want to go over with everyone. So we'll get going. I would just like to welcome everyone. Good morning. Thank you for joining us. This is the Mass MEP webinar event today, and it is presented to you from Design Point. So our webinar today is Additive Manufacturing, the New Normal. We kind of put a little spin on this today. So if some of you have forgotten already or haven't already been tricked by maybe a child in your home, a spouse, a partner, whomever it may be, is this an April Fool's joke, or can we really print something from a part on our machine for a machine on our shop floor? And this is in the webinar. Andrew is going to discuss a little bit more about the additive manufacturing roadmap, where we are in the current state of additive manufacturing. Then he's going to dive into what 3D printing actually is and some common technologies and their applications. And lastly, he has a fictional company where you'll be able to learn where the average engineer, machinist, and factory worker is using 3D printing today. So that's what we've got planned for you this morning. I'm Haley Steele. I'm the marketing manager with Mass MEP, and I'll be the moderator for this webinar. However, as you can see, we do have a few panelists on with us today. Our panelists are Rich Sullivan. He is our Advanced Manufacturing Technology Manager with Mass MEP. And we have two esteemed professionals from Design Point with us this morning. We have with us Sarah Huyum-John. She is the Territory Manager with Design Point. And we also have Andrew Garchik, who is their Additive Manufacturing Specialist and Application Engineer. So Andrew's the one that's going to be running through the real meats and potatoes of the webinar today, but they'll both be talking to you quickly. You can see that you are in a webinar format, so your mics are muted, but we do have some ways for you to engage with us this morning. Down on your bottom ribbon, we have a Q&A section, and we also have a chat. So if you would like to, you can click into the chat. If you have something specific you want to talk to Andrew about, maybe a question you have for Rich, please go ahead and go in there. But if you have a question that is regarding what the content is today, more than likely somebody else in the audience is probably going to have the same question as you. And so we always encourage you to go in and do the Q&A. We will be doing some polls. They'll be popping up. So look for those and just answer those. It's a nice way for Andrew and Sarah to be able to kind of gauge where you as an audience are and what your needs are for the content that they're providing to you. So please feel free to do so. We do have an hour set aside for the webinar. We feel it's plenty of time for the content and the Q&A. We will be respectful of everyone's time on this for our audience and also for our speakers. So if for some reason you have a question that does not get answered, we will make sure that we have that question passed on to Andrew or Sarah, and they will be able to answer the question directly to each of you. As you do have, you did register for this event with your email address, so that's how they can get a hold of you. Just a couple of things for us at Mass MEP. We are recording this. We do use this for internal training purposes, so it is proprietary only to Mass MEP. And also we are live on Facebook. So hello everybody out there on in Facebook land. If you guys have questions out there on Facebook, please feel free to go ahead and chat, put them in the chat in Facebook, and we will answer them. We'll be able to engage with Andrew and Sarah as we go along this morning. The Facebook page is a place for us. We kind of use that as our DVR. So if you have somebody on your team that couldn't make this webinar this morning, that will live on our Facebook page, and they can go in there and they can watch the video. So I'm going to get it started. I'm going to turn it over. So Rich, the floor is yours.
Thanks, Haley. Good morning, everybody. Thanks for coming. And hope you're enjoying April Fool's Day. In honor of April Fool's Day, we're giving a 3D printer to the millionth person who signs into this presentation in the next hour or so. Give you a quick introduction to MEP in general for anyone who is not already familiar. We are part of the NIST MEP National Network, and our only job is to help small and medium-sized manufacturers. So we are largely government funded. We're a nonprofit, and we have no industry bias to any particular technology or company, but we have to involve business partners that have expertise in areas where we don't, and that's where Design Point comes in. But we are, like I said, we operate in all 50 states and Puerto Rico. Many states have multiple MEP centers depending on the size of the state and the arrangements they have, but anybody can contact their local MEP and take advantage of the programs that we offer. So Mass MEP's job basically is to create economic impact. And we do that with a number of programs. Our three basic pillars are operational excellence, which is all sort of bottom line, cost savings measures, lean quality systems, continuous improvement, that sort of thing that affects your bottom line. We offer workforce development and training programs to empower your workforce and to basically get the most productivity out of them and to keep them engaged, which keeps them working for you. And we have growth and innovation services, and those are sort of the top line revenue generating programs, sales and marketing, training, that sort of thing. And the innovation space right now is the emerging Industry 4.0 technologies, which are basically just advanced ways of manufacturing. And we'll talk about more of that in a bit. In addition, I want to introduce you to a couple of interesting newish features that we're providing. One is the NIST Supplier Scouting Program. This was actually mentioned in President Biden's executive order. With all the problems with the overseas suppliers and you know all the problems that are coming up with supply chain in general outside the U.S., there's a much higher focus now to source either parts or materials or processes domestically. And we can help you out with that if you're having any issues finding or replacing a supplier. Essentially, you fill out a form, we put that out to the national network, and then the other 50 MEP centers can try to find a source for you. In addition to that, There's the Matter program, and this relates to technical issues you might be facing. If you have a material problem or a process difficulty or something that requires some technical assistance and possibly a research scientist to figure out. NIST has a series of national laboratories with hundreds of PhDs on staff. And we have access through the NIST MEP program to help you with that. And they'll actually cover up to $50,000 of that cost, depending on how involved it is. So again, it's one of those things where if you're having a technical problem that's keeping you up at night, it might be worth contacting us and seeing if we can help you out with that. We also have a very close tie with Manufacturing USA Innovation Institutes, and these are 16 or so now that have been stood up. They're public-private partnerships, kind of like federal laboratories. And these are dealing with all kinds of emerging technologies that are considered either strategic to national security or the US economy going forward. And again, part of our job is to help transfer that technology down to small manufacturers. In Massachusetts, we're lucky enough to have the M2I2 grant program, which is a innovation-related capital grant that applies to capital equipment or facilities that relate to these technology areas. And there's a website there, you can check that out, or call us if you have any questions. There's a little video here that gives you a quick idea of where things are going for the future of manufacturing.
Since the time of the earliest tools and the mastery of fire, technological progress has been an integral part of being human. By utilizing technology, we have surpassed the most efficient and capable life forms on our planet. But in a world of ever-increasing complexity and finite resources, we are now presented with a whole new set of challenges. How will the next industrial revolution change the way we live, and quite possibly, what it means to be human? Throughout history, there have been periods of remarkable innovation. The first industrial revolution created new goods and new jobs through the introduction of manufacturing. The power of water, iron, and steam helped bring manufacturing out of our homes and into a larger world. Cities and opportunities grew. In the second, we forged better materials such as steel, harnessed the power of oil through internal combustion engines, and utilized electricity through generators and transmission lines. We catalyzed manufacturing and expanded what was possible. After the digital revolution, we possess computers so small they can fit in our pockets, and they're 1,000,000 times cheaper and 1,000,000 times more powerful than the best supercomputer only 25 years ago. Connecting through the internet has encouraged an incredible library of knowledge, setting the stage for the greatest revolution yet. So what is the fourth industrial revolution? Industry 4.0 involves a range of new technologies that are fusing the physical, digital, and biological worlds and impacting all disciplines, economies, and industries. Central to this revolution are emerging technology breakthroughs in areas such as robotics, artificial intelligence, the Internet of Things, autonomous vehicles, nanotechnology, and 3D printing. These technologies can improve lives, create new jobs, make goods cheaper and better, and impact the world in ways we have yet to imagine. While it's remarkable to see the current trends, it's important to remember that technological progress is not simply guaranteed. It requires people to make it happen. This is your opportunity to get involved. This revolution does not happen without your help. Now is the time to be imagining. Now is the time to be creating. Now is the time to be a manufacturer.
Discover how the MEP National Network helps manufacturers. Visit the website below or contact your local MEP center at 1-800-MEP-4MFG.
I think that's a pretty cool video. I like that. Anyway, so our strategy here when it comes to these advanced manufacturing technologies is just to demystify them and de-risk them for you. So just explain in real terms or basic terms what they are and what their value is and how they can help your organization. And not everybody is going to be in need of all these technologies right away, but it's one of those things where you want to at least have them on your radar screen. Understand that your competition is looking closely at all these things to try to save money and improve cost, quality and delivery of their products. And again, we have access in many cases to state and federal funding that can help you with these things. And that's where we talk about de-risking, because if you can learn more about this stuff, maybe you get a chance to play around with the products or the technologies and have it not cost you much. That's a good thing. So depending on who you talk to, you get different answers about what technologies are included in Industry 4.0. These are not new technologies in many cases. They've been around in some cases. The difference now is that they're sort of being integrated with each other and with an overall digital twin, if you will, of your factory, so you have better insight and better visibility into what's going on. Also, the costs have come down considerably and the quality's gone up considerably, kind of like the computer business. What we're going to focus on today is the additive manufacturing, which is just what it sounds like. It's your typical machine shop will take a giant block of material, they just carve away a bunch of it, throw that away as scrap, and end up with a finished product. And the idea behind additive manufacturing, and you probably saw the pyramids in the video, is you start with nothing and you build up from there. And that way you're not throwing away material when you're done. It also opens up new design language and abilities to create shapes and holes that aren't round or straight. You can do all kinds of interesting things with it that open up new possibilities, basically. And with that, I'm going to introduce Sarah from Design Point, and she'll introduce Andrew from Design Point. And they're going to take over from here and explain all about additive manufacturing.
Awesome. Thank you very much, Rich. And we certainly want to thank Mass MEP for hosting Design Point today as we share with you why 3D printing is kind of a big deal. So as Rich mentioned, my name is Sarah Kuyumjan, and I'm the additive manufacturing specialist for Design Point up here in New England. At Design Point, we represent additive technology from Maine to Virginia, and we're proud to be able to help manufacturing and engineering companies throughout Massachusetts and all of New England, really understand why additive manufacturing is a big deal and how it can impact your business. And to give you a little bit of background on Design Point, we're a growth advisory firm for for manufacturers and engineers. And our motto has always been more is possible. And that's because we enjoy working with companies who are in the engineering and manufacturing field and do want to find inefficiencies and adopt new technologies like Rich was speaking about to help grow their business and become more innovative. And so we're going to start off with a quick poll, and we want to ask everybody where you think 3D printing might be used in manufacturing today. What are your thoughts on that?
Okay, and we will keep it rolling here. We'll go back and look at some of the other poll answers when we get to the end here. But I'm going to jump in. My name's Andrew. I'm an application engineer with Design Point, and I really appreciate you guys jumping on today and spending some time with us. I put together a presentation. I kind of didn't hold back this time. I put in some jokes and 80s memes, and I tried to make it fun and make it a little more exciting. But there's some great info. Which we'll cover in a second. But my job at Design Point is working with, manufacturers and engineers and the government and helping them evaluate this technology, this, new 3D printing technologies that are constantly coming out, and helping them decide, is it a good fit for them? If so, how are they going to use it? Looking at applications. I also help implement the technology. So I do training and installation. And I also support customers after the fact. We have a system called CSM, Customer Support Management, that we keep in touch at a regular cadence with our customers, making sure that they're successful. And last but not least, I manage our metal and composite 3D printing facility, which if you can see my screen, that's where I'm hailing from today. That's our metal printing system right there. And we've got a couple composite printers over there. So this is where we make high strength parts for manufacturers. And oh, I almost forgot, I have a side gig. So I moonlight as a college professor for the Catholic University of America. They're in Virginia, so I teach a remote class. I'm in New Jersey. It's MSc 526 Additive Manufacturing Systems, which is, more or less like an introduction course for 3D printing and where it fits into modern manufacturing. All right, looks like we got some results there. Most people say all the above, and we got a couple folks who see it more as a prototyping tool. So let's get into the content here and see if we can learn a little more about that. So the agenda, it was covered, we did, so I'll just touch on it here. We did some introductions already, that's done. The first thing I'm gonna talk about is what's additive, right? What's additive, what's 3D printing, what's the difference? So that way we start off kind of at a baseline and really build from there. And then the next, the AM roadmap. So the context of the 3D printing industry, which is really important, where we were, where we are, and where we're going. And then next, I got a little creative and I made a fake company called Curie. So it's a fake company with real use cases. It just seemed like a more fun way to present to you guys some use cases and build them into a story where we'll follow my fake cousin who just became the new efficiency manager over at Curie, and how he looked at the different departments and made them more efficient with 3D printing. So first, chapter 1, what's the deal with additive manufacturing, right? What is it? I apologize. I promised everyone I would do that. So, so what's additive manufacturing anyway? Well, it's not subtractive manufacturing. It's the exact opposite. So subtractive is where you take a big block of material, right? Picture like a sculptor with a big block of marble, and you cut away what you don't want until you get only what's left. And in manufacturing, I'm sure everyone watching knows this, but just for those of you who maybe don't, what it looks like in manufacturing is you take a big block of metal most of the time and use, maybe a mill to cut away until you get, again, the desired object. And what's the kind of the downside of subtractive manufacturing? Like, why aren't we done? Why don't we just have that and then we don't care about any other stuff? Because it leads to waste. It's inherently not as efficient as additive manufacturing. So if that's subtractive, then what's additive? Well, additive is where you add material until you get your desired object instead of subtracting. So the obvious one is 3D printing, right? Everyone, when they think additive, they think 3D printing, and that's where you build it from the bottom, layer by layer. But also, there's but there's definitely some traditional technologies that maybe aren't considered additive. But I would like, if you look at injection molding, so you don't take a block of plastic and cut away what you don't want to make a Lego. You inject the exact amount of material you want into a mold, and it pops out the Lego block. And there's little extra bits that you cut off, but it's the same with 3D printing. 3D printing has support material you cut off, so it's kind of similar to that. So I would consider injection molding additive. And like Rich mentioned, the pyramids, right? Block by block, that's additive manufacturing, right? This has been around since the beginning of time, right? Folks have been finding ways to do additive manufacturing. So if that's additive, then what is specifically is 3D printing? Well, 3D printing is obviously the process by which nerds make Baby Yodas. And if you don't know what a Baby Yoda is, you're probably not a nerd. That's from a show called The Mandalorian that's out now. There's a little Baby Yoda. But okay, yes, that's of course true, but we could do a little better than that, right? So what is 3D printing really? It's a subset of additive manufacturing, which is the construction of a three-dimensional object from a digital 3D model. So what does that really look like? Well, an engineer gets in front of a computer and they use some what's called CAD software to create a 3D model. So they're just modeling it on the computer. Then the model that they generate goes into a slicer software, and all the slicer software does, in essence, there's obviously more, but it breaks that part, the 3D model, down into different layers. Okay, so that way when it goes to the next step, which is the actual 3D printer, the AM process, now it has instructions, so it knows what exactly to do layer by layer as it builds the part. And that's exactly what it does. It builds it layer by layer with one method or another, which we'll go into in a second, until you get your final part. So some of the most common types of 3D printing, and I'll tell you, there's a lot, right? There's no 3D printer that you buy that does everything. Each different type of technology is a different tool in your toolbox. Some are good for some things, some are good for others. It's just like, you know, a hammer or a screwdriver. It depends. Are you trying to nail a nail or screw in a screw, right? There's a different tool for a different job. So probably the most common type of 3D printing out there is FDM, or it's called FFF as well. And that's where you have a spool of material and it feeds through a hot nozzle and it builds your part layer by layer. So any printer that you've ever seen that has a spool like next to it or attached to it, that's FDM 3D printing. It's the most simple form in my opinion. And what it's good for is making strong parts. They actually have technology there where you can run continuous fibers like carbon fiber or Kevlar into plastic using FDM technology. So you can make really, really strong parts. Like you can make composite that's metal strength. You can make really big parts. Most of the large format printers, as a matter of fact, I don't know any large format printer that's not FDM, but I could be wrong. I'm not completely an expert in that field, although I do have some exposure to it. But mostly big parts are FDM, and in manufacturing, it tends to be FDM 3D printing. SLA is also a really popular form of 3D printing. It makes very, very high accuracy parts, very high surface finish, very good detail. So in the past and today, it's used for rapid prototyping. But the way that works is you've got a vat of resin. It's a photopolymer resin. And then you hit the bottom of it with a UV light. And only the spots that the UV light hits gets cured. It's kind of like when you go to the dentist and they put a filling in, then they take that UV gun and they hold it on there to cure your filling. It's kind of like that, but it's curing a plastic. And then it moves down and a little more of the resin can flow underneath, and then it hits it again with the light, and again it builds it by layer. And then you've got DMLS, which is a powder-based metal system, and it lays a layer of powder down, and then you hit it with freaking laser beams, man. There's a laser, and it hits it, and it sinters it on the spot, and then it drops and more powder goes across and it hits it again with the laser. And again, it builds it layer by layer. That makes end use parts, right? These are metal parts. These are high strength. So you could use them for just about anything. All right, so poll number 2. What are the best uses of additive manufacturing? This time I didn't put in all of the above. I didn't want to, I want to get your opinion. Is it saving time? Is it saving money? Is it flattening your supply chain? Is it manufacturing efficiency? Maybe there's no wrong answer here. Just kind of curious what you guys thinking, what you're thinking, where your head's at with that. All right, so we will keep it moving. Well, it looks like we got a lot of manufacturing efficiency going on. All right, well, that's what our webinar is about today, so that's cool. All right, we'll keep it moving in the interest of time. All right, chapter 2, the AM roadmap. And I chose this picture very purposefully. We used to be crawling around like monkeys, and now we are sprinting. So I want to give you guys some context as to where we were, where we are, where we're going. So let's start by going back in time, right? Go back 10 years, go back 15, pick a number, but let's go back in time. And what kind of headlines were we hearing? Well, 3D printing is going to change the world, right? It's going to be flying cars and laser beams. And I had a friend, excuse me, come to me and say, yeah, when you order something off of Amazon in the future, they're not going to send you the item. They're going to send you a file, and then you're going to have a 3D printer in your house, and you're just going to put the file in, and boom, you're going to manufacture your object right on the spot. And then another friend said, you're not even going to have to buy a candy bar. They're going to send you the file for that, and you're going to have a printer in your house that has chocolate and white chocolate and delicious nougat, and it's just going to make the new Hershey bar for you. But what did we really see, right? And not today, but that's different. But in the years to come from then, like what did we see for a lot of years? We got a lot of Yoda heads, right? And look, Yoda heads, speaking as a nerd, like they're cool. Like I like Yoda heads. But my point is the parts, they were not very functional. They were not highly accurate. They weren't very strong. They weren't very chemical resistant. Just they didn't have a lot of these properties that people needed to have, for their different applications. So what happened, right? Well, let's travel now back to present day. Okay, so now our phone booth time travelers on the left, They're no longer the young teenagers that they were. They're now the middle-aged, shriveled up guys on the right, just like all of us who saw the movie in 1991 in the theater. So now we're back to present day. So what's going on today? Well, in China, they built the world's tallest 3D printed building, 5-story building, pretty insane. I knew a really good use case from the University of Maine where they 3D printed a giant boat. So I went to look that up and I found this article. 3D printing boats is becoming standard practice. So that's neat. Researchers just printed the first ever complete human heart using human tissue. So look, it's far away. The heart doesn't beat. It doesn't have muscles, but it's a start to that. And with soft robotics technology that I've seen coming out, I bet that thing will be beating soon. And we're closer than we think to organs. And then not last month, now it's in the month before last, in February of 2021, NASA landed the Perseverance rover on Mars with metal 3D printed parts on it. And I have this quick little video that's neat here. This is a digital, oh, there we go. It's a digital representation of what actually happened. So this actually happened in February. And some of you are looking at it and going, oh, of course I know this happened. And others will watch it and go, oh my, I can't believe that this is real. It looks like a movie, and it's got the movie trailer music behind it too. So. Okay, so that happened in February with 3D printed metal parts on it. So think of how far we've come. 10 years ago, we were doing Yoda heads, and now we got parts on Mars. Awesome. So where are some other areas where it's infiltrating, regular society? Well, consumer products. Gillette's got a new custom razor. You can get your custom 3D printed, handle for your razor. And think about the competitive advantage that really gives to companies. Now customers can make a personal connection with their item. This company called Revo unveiled the first 3D printed bike with continuous carbon fiber in it, which is really, that's how you make the strongest 3D printed parts today. So it's not just a replacement for a bike frame. This makes a better bike frame. This makes a bike frame that's got better geometry, that's lighter weight, that's got a ton of strength. So this is an improvement on previous frames. And Dr. Scholl's, you can order custom 3D printed insoles. Looks like you can go on an app on your phone and pick the one you want. You hit a button, it shows up at your house. And dental liners, Invisalign, Smile Direct Club, all of the molds that are used to form dental liners, those are all 3D printed these days because they have to make a bunch of different sets for the different changes that your teeth are going to go through as they improve through the process. So lots of consumer products. You're also seeing 3D printing and construction. This company Icon just put the first US 3D printed homes up for sale in Austin for $450,000. They're printed using a Vulcan concrete printer with a material called lavacrete. And their proven 3D printing technology provides safer, more resilient homes that are designed to withstand fire, flood, wind, and other natural disasters better than conventionally built homes. Again, this is not just a replacement, this is making it better. It took 5 to 7 days to print each house, and Icon claims that the Vulcan can print lavacrete more accurately and at a higher speed than manual labor, so the houses are cost effective and well built. And again, it's not just changing the way we do things, it's about doing it better and more efficient. And I just love that these homes are 450 grand. These aren't experimental tiny homes that they're printing for homeless people. These are homes that are legitimately competing on the market with some pretty sweet homes. I bet they're designed to compete with homes that cost $550,000 on the regular market. But one of the biggest impacts, and this is Design Point's area of expertise, and this is the focus of today's webinar, is manufacturing efficiency. So I'm sure a lot of you folks watching know about tooling and fixturing, but if you don't, real quick. So when I say manufacturing efficiency, mostly I'm talking about tooling and fixturing. So what's that? When a manufacturer makes parts, they got to make the parts that make the parts. So they have to make tools, custom tools, and every manufacturer is going to have different tools that they have to make. So there's fixtures, there's end of arm tooling, there's molds, it goes on. And just to give you an idea, this is a retired Lego mold. This makes those little Lego blocks I think, did I have one earlier? Might have been a different presentation. But it makes the little square Lego blocks, and so this only makes one block too, right? This is a mold just for one particular geometry. And I want you in your head to picture what you think this injection mold costs. Just come up with a number, whatever you think it costs. Oops, went the other way. Was it 200,000? I bet not that much. So that's what according to the article I was reading, that's what that mold costs. So it's a big deal. So when manufacturers can start to replace fixtures and tools and molds and dies with 3D printed parts, they can save tons of money and time. And we're gonna show you that in the Curie Force bit. But the according to Gardner Intelligence, which is where I got this information, the U.S. spends about $8 billion per year on tooling. And it's said that the biggest automotive manufacturing companies spend $1 billion or even more with a B dollars per year on tooling just for each individual one. So it's a big deal. And the global spend is about $80 billion yearly. And if you look at this chart, which shows you from 1960 to present day, it's just going up and up. I mean, there's years where there's a recession or manufacturing falls off and there's a dip, but if this was like a stock, I would want to own this. This is going up and it's going to continue to keep going up. So 3D printing tooling is going to be more and more important. And folks who are finding ways to do it are going to be getting a serious competitive advantage over their competition. So why all this stuff I just showed you? So why is this the case, right? What's been going on? How do we go from Yoda heads to Mars in 10 years? Well, this is a report from Wohler showing the size of the additive manufacturing industry worldwide. And 10 years ago, we were at 1.5 billion. Today, we are at 10 times that. We were at 15 billion. And they think that in the next 10 years, or even less now, this is just till 2030, it's going to 10x again. We're going to be at 150 billion in just 10 more years. So it's an exciting time to be in the 3D printing industry. This is explosive. We're seeing explosive growth. And it's just infiltrating all different industries. And we're seeing it in electronics, government, education, aerospace, medical, product development, right? Remember when rapid prototyping used to be the #1 3D printed application? Now you got automotive and manufacturing just generally above and beyond that. And you can see here, manufacturing is 50%. It's as big as all the others combined. So that's where we're really seeing, a ton of use coming out of 3D printing these days in manufacturing. And this is from a survey of companies using 3D printing and what types of materials they're replacing. So what are they 3D printing now versus, traditionally? And they're replacing steel, aluminum, and plastics is third. So these are real end-use parts. This is not just prototyping anymore. All right, so now to further get into manufacturing efficiency, we are going to look at Curie Force, which is the fake company I made with real use cases. We're going to follow my fake cousin, Vinnie. He just became the new efficiency manager. So we're going to see what he did to make Curie Force more efficient. And first off, why Curie Force? Well, I named the company after Mary Curie because she's a rock star. She's the first woman to ever be awarded a Nobel Prize, and it was in physics. She's the first person, man or woman, to ever be awarded a second Nobel Prize, which was in chemistry. So she got physics and chemistry. She was the first woman to receive a PhD from a French university, first female at the University of Paris. She discovered radioactivity, polonium and radium, and she heavily championed the development of X-rays, so much so that in World War I, that's around the time when she was around, she developed what were called little Curies. They were mobile radiology labs that had X-ray technology in them, and she learned how to drive a truck and maintain it. And we're talking like, early 20th century. It's different these days, doing that. So she learned how to do that, and she drove one of these. There was about a dozen of them. She drove it around near the battlefields to these field hospitals and actually helped save lives with X-rays. So she's awesome, and I just wanted to bring some awareness to her, who she is. So I named the company after her. But we're going to be looking at 3 different areas: research and development, right? Where does the engineer use 3D printing? The regular engineer. The shop floor. Where does the machinist use 3D printing? The machinist who goes home with grease on their hands. And then last, final assembly. So where does the factory worker use 3D printing in their everyday job? How does 3D printing help them be more efficient? So first off, let's look at research and development. So The challenge for cousin Vinnie was to improve prototyping processes to bring products to market faster, right? They're getting creamed by their competition. They don't understand why. The competition's getting parts out to market faster. So his challenge was to fix that. So what's the status quo? Well, every part that they design for a new product, it's got an average of 3 iterations, meaning they have to change it 3 times. And every time they make a design, they outsource the creation of it with a 6-day lead time. So being that they have to do it 3 times, that leads to a cycle of 18 days per part from when they design it to when they have the part finished, and then they know that they're ready to go. So what did cousin Vinnie do? He stopped outsourcing the parts to a printing bureau, and he's brought the technology in-house, and he changed the way that they prototype using 3D printing. And coincidentally, it just happens to be the same exact thing that happened to Brooks Automation. So they manufacture automation equipment that handles high precision, fragile products like semiconductor wafers. And to handle these parts, each machine system is precision designed, so much so that some parts could go through a few iterations before being finalized. Same thing, right? With conventional manufacturing methods, each iteration stretches the development timeline by several weeks. And in an effort to shorten its development cycle, Brooks added high-strength 3D printing to its workflow. By utilizing continuous carbon fiber 3D printing, Brooks drastically shortened its prototyping process. So they use carbon fiber to make these prototypes that were actually not even possible with traditional plastics. They need to go to a composite for a more functional prototype. And you can see the metrics here. Went from 18 days to only 36 hours to make 3 different parts. So that means it took them about 12 hours to 3D print this part. And the cost was dramatically reduced from $1,200 down to only $125 for the parts. That's 92% time savings, 86% cost savings. So now for the shop floor. So the challenge for Vinnie was reducing tooling costs by 10x. Wow, that's a big one. Get that as a mandate from your boss. That'd be a lot. And reduce lead times on tools as well. And the status quo for Curie Force, they got high part costs and a lead time of about 4 weeks from their internal machine shop. So you might say, wow, how they're waiting from their internal machine shop, but that's common. I see that out in the field all the time. Their machine shops are so busy that you have to get online for your parts a lot of times. So the solution, shift tooling creation responsibility from the internal machine shop to the engineering department using 3D printing, right? So think about that. When you're making tooling and fixturing, when it's done on the traditional methods, that's a machinist who has to work on that. By switching to 3D printing, now an engineer works on that, he prints it and he hands it off completed to the machinist who then uses it in their production. So this is not just changing the way that you make the part. This is changing your whole business. This is switching it from a machinist who are a dying breed these days. They're hard to find, good talent. They're usually swamped at work, making them happier, having them better job retention for them by switching the some of their job, not the most important, but switching some of it to 3D printing. And that's exactly what Lean Machine did. So Lean Machine is a metal fabrication shop in Saskatoon, Saskatchewan, believe it or not, specializing in custom machining with a 5-axis mill. And they created a number of different tools to support their operations, including fixtures, press brake tooling, and the robotic arm grippers that you see here. So the way this works is they've got an automated cell that's got a robotic arm. It's got these metal grippers on the end that pick up a little piece of sheet metal. It puts it into a punch and die set in a press brake that is actually also 3D printed. So that's kind of neat. This is a twofer, 2 for 1 here, 3D printed punch and die and 3D printed grippers. So the punch and die bends a little piece of sheet metal, and then the robotic grippers grab the piece again and put it into a pile. And that's all it does all day. It sits there and goes back and forth and does that. And traditionally, they were paying about $434 once they added up the material for those grippers and the machinist time and all the other factors that go in. And it was taking them about 4 weeks to get the part because there's such a bottleneck, in their internal shop. The 3D printed cost was only $64 to make those metal grippers, and the time was reduced to 4 days. And actually, if you look at my screen now, I've got the next version of that they made, which is a hybrid version. They decided to mix the two technologies. They 3D printed the tip in metal and the body of the tool in a carbon fiber composite. So this actually further reduced the cost of the tool down to $30-something, so it halved it. And they can produce this in only 3 days. So it took like 25% off of that even, better adjusted 4-day lead time. So, mixing parts and technologies, that's how you take it to the next level. Oh, it looks like someone forgot to add an animation to their slide. So now we're in final assembly, and the challenge for Vinnie, quicken throughput by improving their manual processes. So they've got a bottleneck at the point where the products have to be physically put together by folks, by factory workers, right? That's all they do all day, they're sitting there putting together products. So it's manual and it's slow in products getting out the door. So what did Vinnie do? He improved the assembly speed by printing assembly fixtures to aid the factory workers. So what does that look like? Well, that's exactly what Caldwell Manufacturing did in their facility. Shocker. Caldwell Manufacturing is a global window and door hardware manufacturer based in upstate New York. And for any piece of window or door hardware that they make, the team at Caldwell also needs to make assembly fixtures, which are designed in-house and cut from steel through a third-party supplier. The internal tooling often took up to 8 weeks to design and develop, and certain components had to be sourced from overseas, which led to product development cycles of anywhere between 6 to 12 months. The same parts that would previously cost anywhere between $300 to $5,000 if made using traditional methods now cost $30 and takes only 3 days to produce instead of up to 8 weeks. And for me personally, in my experience, that's the big what to do. It's the time savings. I mean, it's great to save money on parts, but you can't buy time. Time is not for sale. So these dramatic, decreases in lead times, that's the big what to do that I've seen for manufacturers these days. But the cost is also nice as well. All right, poll number 1 again. You thought you were getting a third poll? Nope, April Fools, psych. We are doing the same poll again. I just wanted to see if anybody kind of changed their minds. But I think in the first instance, everyone kind of said all of the above, which was, the right answer. Obviously, now you can see that there's multiple ways to use 3D printing in manufacturing through the presentation. And yeah, I've still got some folks say, yeah, assembly fixtures and end-use parts is the way to go. Yeah, that's cool. Yeah, absolutely. End-use parts more and more these days. Cool. Thank you for playing along and answering some questions there for us. All right, so I just want to finish up the presentation here by talking about a course offering that we have. It's created from Design Point. It's offered through Mass MEP. It's about developing an additive manufacturing strategy for 2021 and beyond. It's a 3-day course. We cover a lot. I mean, if your company has some sort of initiative coming from higher up and they're saying, yeah, we want to dive into this 3D printing thing and learn more. Well, this is great. This is going to get, you can tell your boss, hey, I've found this great thing where we can learn everything we need to get going. But maybe your company doesn't have an initiative. Maybe you just think that they should. Well, it's a great course for you to take and show some initiative yourself and go to your boss and say, look at this course I took and all this great information, how we can use it. And maybe you don't work for a company at all. Maybe you're just, on your own and you just want to bolster your resume. Well, you can have this course's background and you can say, look, I know what's up with 3D printing and modern manufacturing, right? It's one more feather in my cap. So whatever your reason is for wanting to learn about additive, this course really has it all. It's really built to be, for everybody. It's got an intro to 3D printing and a technology overviews for those of you who are just getting started, or even maybe like me, like I'm heavy into FDM, maybe you want to learn a little more about different types of technology, get outside your bubble. And then we talk about where 3D printing fits into modern manufacturing. There's a lot of that, a lot of like similar material to what you're seeing, in this webinar today, where we're talking about tooling and fixturing and all these different applications and how they work. And we expose you to additive manufacturing software, so you get an exposure to a couple softwares, kind of just get a feel for what it is, right? The bigger part of the process, how it works. And really important, DFAM techniques. This is really important. It's one thing to get a 3D printer and learn how to use it, but you need to know how to design for the process, right? Every process. We're talking about molding, or you're talking about sand casting, or you're talking about milling or turning, whatever it is, there's a process, a design process that goes along with that. And additive manufacturing is no different. And when you have these techniques for design, you can take 3D printing to the next level and you can save much more time, much more money, and make parts that are stronger and more accurate. And I can't tell you how important it is. People underestimate this design for additive manufacturing and what it means as a skill. And there is application identification. We're going to teach you how to walk your own manufacturing line and identify different ways to use 3D printing. And then the third day, we're going to go to you. We're going to go to your company We're going to seek to understand. We're going to learn all about your company, and we're going to try to help you guys walk your own line with you and identify applications. And look, if you're just somebody who maybe, maybe there's no line to walk, maybe you're just, on your own, like I said, the third day could be coming to our facility, right? You could come to this lab here and you could check out all of our applications, and we can show you, firsthand, how these 3D printers work and what the deal is. So what again, no matter what background you're coming from and who you are, this course is going to be killer, getting you to really understand, where we were and how to utilize it and where we're going and how to be a part of that. So that's all I have for you guys today. I want to thank you so much for your time and checking it out, wherever you are in the world, checking this out. And I got one more meme, couldn't help myself. Wanted to try 3D printing. Look how cute he is. He's like the size of a penny. And if anybody knows the meme that comes from online, then you think that's cool. And if you don't, you're like, what is this? But okay, there it is, one last meme. So with that, I would like to open it up for questions. If anybody has any questions, please type them into the chat, or I'm not sure how we're doing it, but we're happy to field any questions we have right now. And I'll go ahead and unshare my screen so that way you can see our faces a little bigger.
Or not.
Or not.
Or not, yeah. So we also have, we put a QR code in there. And the reason we do that is because what the content that Andrew just went over regarding, where we stand as Mass MEP, and Rich kind of touched on it at the beginning. But you can actually scan that QR code, and that will take you to Rich's information. He can give you a little bit more insight about who we are and how we can help you in regards to getting you registered. And so it's not really registered, but digging a little bit deeper into doing something more specific with the program that we do with Design Point. Questions. I have a question for you, Andrew. So those pieces that went to Mars, all of that was done on a 3D printer, or just sections of it, or like?
To be honest,
Parts of it.
Yeah,
Parts
just
of it, yeah.
parts of it. Yeah, it's definitely not the whole thing. It's just
Yeah.
probably a few key parts, but I honestly don't know exactly which ones they were.
Yeah.
Yeah, it's yeah, I mean, 3D printing is cropping up pretty much everywhere these days, and in a lot of places that you wouldn't necessarily expect. But yeah, from a lead time standpoint, if you need to make something, or if you need to make some really complex, crazy part, or some part that is largely hollow, so you can, with anything NASA does, it's, lightweighting is critical. So if you can make a part that is still completely functional, but is virtually empty on the inside, but still as strong as a solid part, you can't do that with any other means besides 3D printing. So a lot of cool stuff. I've seen bicycle parts being printed. It's essentially like a 3D mesh kind of material. And as long as you have the connecting points, where they're supposed to be, it really doesn't matter what the rest of the material is shaped like. And you can get really, really strong, very lightweight parts, through 3D printing. And, Andrew mentioned the course, this is a 3-day class that we're offering through Mass MEP. It's also grant funded. So, the cost of the class can be either cut in half, or in some cases, completely free to companies that qualify. So, it's virtually no risk. You get a much deeper understanding of where this technology might help you. Obviously, you don't want to go out there and spend a ton of money on something and have it sit in the corner. There's plenty of that out there, and our job is to kind of help you understand and figure out what best suits your particular operation. But yeah,
So,
a question?
yeah, there's a question. Howie's asking the question: does Design Point participate in the manufacturing expos that are, I'm assuming, in Marble or Mass?
Those are the design to part shows, probably. And
Yeah,
no.
so we've done design to part before. I've actually attended those. I don't think we're doing kind of every single one. We're kind of pick and choose, and it's a little bit outside of my area in the company. I think, some other folks kind of at a higher level decide which ones we do, but we do a handful. I mean,
Actually,
we're certainly interested.
I met one of your folks from, they used to be, was it Alpha Additive that merged with you guys, and they always went to the design to part shows. So I said no when I was wrong.
Yeah, I can expand on that a little too, Andrew and Rich. We certainly are looking at upcoming shows that are available as things kind of open up. Yeah, so we will be promoting those, which ones we're attending on social media and our website as well as things open up and we move forward here. So
Yeah, if you don't, I would strongly encourage you, to go on and follow Design Point on their social media platforms. And they also send out a great newsletter as well. So if you can subscribe to that newsletter, that's great. But you can always, a lot of times if there's information, we will repost anything that we see on our side as well when they're doing some kind of events. But feel free to reach out to us if you have any questions, or you can reach out to them and directly and ask them, if there's more information you need. But
yeah, and we're open to recommendations. If you know of a really cool show, something that you go to or you attend that's interesting, just reach out to us on LinkedIn. I'm on there all the time, or Facebook, or I don't even know, Twitter, whatever we're on. And we're happy to take some recommendations.
Yeah. All right. Well, I mean, it's the 55 mark. We usually try to let people go at the 55 mark because we know that if they are living in this world today where they are on Zoom calls back to back, they need a little bit of time to get prepared for the next meeting. So I don't see any other questions or anything. And I think we're going to close it out. We can give our panelists the rest of a couple more minutes back, and the same for our attendees. But thanks everyone for joining us today, and feel free to reach out to us in any way possible, whether it's through LinkedIn or social media, Twitter, our websites, email addresses, however it is, we will answer. So we'll be there moving forward. So thanks everyone, and we will see everybody next time.
Thanks so much, everybody. Appreciate you watching.
Thanks for coming.